Okay, my friends, this is pretty serious. NASA claims they're very serious about looking for extraterrestrial life. That means something that's out there in space or on planets or wherever. Doesn't matter where it is. I dispute that claim. They're claiming right here, NASA is serious about searching for alien life even within our own solar system. I dispute that statement, and here's why I dispute it. Okay, so why would I contest NASA's statement they're looking for life? This is the Bennu mission. I said to my best friend now, chat, tell me about the Bennu mission. Well, the objective, the primary goal was to collect a sample of the surface material from Bennu, this asteroid, and return it to Earth for study, which they did. Scientists hope that studying the asteroid composition will help them understand the early solar system and the origins of life. So it's here back on Earth, and I have analyzed it myself, and I know exactly what it is, and you will too. And I find it very hard to accept that NASA and all the rest of them are interested in the truth of this stuff when they won't talk to me. Okay, so like I say, before I get too deep into this, they have to look at Bennu and look at the samples that came back. I have shown this many, many times. This is Bennu, which is the asteroid they landed on. This is a heart, and the plumbing at the top has ripped off, and what you have left is the valves here, and some of the plumbing tubes sticking out. Those are tubes. Those are not craters. And most of these are exploded places where there was a ton of blood, because the heart is just saturated with blood, not only in the bags, but the whole heart itself is just nothing but a bag full of blood that's pumping continuously to make that thing pump. That thing's huge. Now here it is right here. This is what the valve assembly looks like when you take off the plumbing. And when I say the plumbing, what do I mean by that? You see right here? Valve, 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 all over, right over the top. And then there's some other little tubing sticking out here and there. This breaks off right here. And the reason it does is because it's glued. That's just basically glue. Now, I want to talk to Gil about all this stuff, because this is going to be a fabulous discussion. I believe that this is like a semi-attached, and this is more of a stationary bunch of tubing that really doesn't move a whole lot, but that has to do all kinds of stuff. So that's a discussion I'd like to have with Gil. But I can tell you what, right now, that's a heart. And so is that. And Psyche, this one over here, is the same. No difference whatsoever. However, it is smelted a little bit. And what does that mean? Blood is almost all metals. There's some metals and some plasma and some water and a few little other chemicals, but mostly metals. Because that's what your body runs on, is metals, transition metals. All this right here. All of this stuff, and iron is the primary one, but all of this other stuff has to move chemistry around your body using charged particles. They call them ligands. They surround the metal core, and they drag them around. They have a charge on them, and they drop them off if somebody else wants it more. That's how it works. And when you die in the conditions of mudfossils, where there's they can stabilize, just like that heart stabilized in space somehow. Now, they said in the ancient text that there was battles in the heavens, and they said there was actual creatures battling in the heavens. This is written in all the ancient texts, every single one of them. But everybody just laughed at it. Oh yeah, they must have meant there was this constellation doing this to that. Well, I don't know. I'm seeing hearts. I'm seeing everything else, everything out there. And I have meteorites here. I have at least 3. Well, actually, I have 4. And one of them is a giant fingertip. Well, here it is right here. Hold on. I know this is crazy, but I have everything I'm talking about. That was a fingertip. And at one time it was complete. Came all the way down this way here and straight across the back. You see how flat that is? And why did this explode? Well, it exploded. Why is it missing, I meant to say, from here to here? It exploded. It was red blood, and it boiled and blew out. This side is where the veins are. You see that black spot right there? You see that black spot? That's a vein. And there's a vein up in here too that didn't blow out. They don't blow out. The veins don't blow out. But everything is scorched off. Now, I tried to figure out how this must have come into the atmosphere and not just really destroyed everything, but it got so hot that it exploded all the red blood. This is the artery side, red blood, fluidy. Boom! This side just cooked solid. That's what happens with the black blood. Now, how did it enter the atmosphere without just burning up and cooking up and being totally 100% destroyed? We can see it's all scorched and everything, and actually, you see that right there? That's a tendon attachment. There's another one here, and then there was another one over here. This thing is so perfect as it cooked off all the flesh. So, this is the part missing. Exploded out. How could this have not been destroyed? Well, here's what happened in my mind. It probably came in with the same spin as the Earth is going. So it wasn't going opposing like this. It was coming in with it at night. So at night means the temperatures are way different at night out in the ionosphere than they are in a day. In a day, everything just cooks up because it's unbelievably hot. But at night, it comes down quite a bit. Not a bazillion degrees down, but a lot. So I believe this came through at night with the rotation of the Earth. That's why it cooked up enough to boil up the blood and blow it out and sort of singe off all the meaty stuff, and then you're down to the actual building block of the finger. Isn't that something? Now, I have one here. This is really something. I have one here that was a terrestrial fingertip. You see that? Look at this carefully. Hold on one second. I want to show you this so you really understand, because this is just crazy, but it's true. Identical structure, and that's where the red blood was on this one, and it leaked out. It didn't blow out, it just leaked out. And the black blood, you see, sealed off the same places here as over here. Even the hook, that hook right there, is the same hook. The tip is the same tip. Over here it's the same, only this one just leaked its blood out. You see there's one at the tip. There'd be one under there too. This is all where the red blood is. You can see it's red. And that's where the red blood is here, and you can see it is red. From outer space, from Earth. Now, are they really looking for things? I've been trying to push this on them for years and years. And anyway, University of Arizona, I believe it is, I've been trying to contact them about looking at this in this light, and just see if it's right. I could be totally wrong, but I don't think so. I think I have enough evidence to support what I'm saying. When I show you the sarcomeres and all that, I did. I'm sure I did, but just to be sure, these are sarcomeres. That's actually a heart, and this is, like I say, I got most of my stuff from autopsy stuff, and this is ripped muscle, and that's the real good, still perfect sarcomeres. But once they're ripped, it's your torn muscle. Now, you see these layers in between? Those are the phosphate layers. The rest are the sarcomeres. And I showed you from Bennu, that is precisely what they found. The phosphate layer below and above, sarcomeres in the middle. Here they are right there. There's the sarcomeres. And there they are right there. That's a heart, that's a heart. These are hearts. That's a heart, Bennu. And the size of these things, Bennu is, I think, 1,500 meters across. I don't really know. I don't want to make that statement. But here's up on Mars. I reported this to NASA 10 years ago, that these are muscle sarcomeres. And that red dust, it's a red planet because it's basically blood cells. It's just dusting off of this muscle sarcomeres. And not only that, they're saying this was continually over millions of years. No. This was when it was impacted by Venus. And when I say impacted, I'm talking impacted. Wider than the United States. Wider than the United States. Deep and wide. Now, that's the Mars Marianalis Vallis Trench. I'm not sure how they pronounce it, but that's close enough. And that was the impact. Now, what else is up on Mars that shows that it was alive at one time, just like Earth is? Well, there's the Mars crab. Again, I sent this to NASA. I said, this is biology. That is an artery. That is a vein. You see that? That is an artery, and that's a vein. And what they said, all these little crab legs sticking out. And this was big news in 2015. Oh, I found a crab on Mars, and then everybody laughed. And NASA put out all this stuff. Oh, these crazy people, they're making up things in their parody. Oh, they just don't know what they're doing. And then they dropped it. And it was asked to be investigated, and they said, no, we have other things to do. Basically, I believe that was, I know, I asked them to. And I don't think they responded. I can't remember. I know they didn't respond, basically. Or they didn't respond. Now, that's where it is. That's where that crab is. And what's this? These are the muscle sarcomeres. You need a ton of red blood to pump into these sarcomeres. This is fully understandable. And this is Mars because there is no erosion whatsoever. Did you see that other picture here with the sarcomeres? These sarcomeres, 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 sarcomeres everywhere. You see how there's no erosion whatsoever of water. Water would give you little bitty rivulets here and there. This is just dust. And it's just dusting out because it's the weak part, and this is the structural connective tissue part. Simple as that. Okay, we're going to take a look at the samples in a minute, but this is what this surprising phosphate finding. Surprising phosphate finding. This is at Washington University. Phosphate in NASA's asteroid sample. Surprising phosphate. Bennu holds the solar system original ingredients. Now, University of Arizona, I'm trying to get through to them. They won't talk to me. I know what this thing is. And they are the ingredients of life. Now, it goes on and on. CNN, phosphate finding. You can't miss it. But they did miss it. You see this? We're talking about cell membranes. Cell membranes. They're phospholipid bilayer. 2 layers with phospholipids. Well, they're phosphorus on the outside, lipids on the inside. Well, all right, we are talking about the phospholipid bilayers, which are membranes. And I will show them to you in a minute. But this is the key takeaway. Phosphates are a critical component of phospholipids. But they're not just doing nothing, they're just floating around, part of the structure. They organize the phospholipids in a way that allows the cell membrane to function. There's watery heads and then there's fatty heads. And the fatty goes to the inside and the watery heads go to the outside. And that is what organizes them, is the phosphates. They're not just there for nothing. That indicates life virtually 100%. Okay, my friends, this is the sample from Bennu. What is it? It's very small. This is only 1 millimeter, this big, so it's not huge. But it was what they brought back, and they have been distributing this stuff to universities and so forth and labs to look into it. Well, I can tell you what it is without any of that stuff. This white stuff right here, that's the phosphate. And it's 2 layers. There's a layer underneath and a layer above. Okay, so it's 2 layers, and then in between is this stuff. That's pretty interesting. Phosphate is the organizer of cell membranes. I just read to you, that's what it does. And it's on top and it's on the bottom of these blocks. Well, what are those blocks? Those are pretty specific looking blocks. Those are not just nothing. Those are quite interesting. They're like chunks of wood, like somebody sawed them, and then they have like almost like a bark of a tree or something, but it's not. I can tell you exactly what it is, and I will show you right now what it is. It is muscle sarcomere. Okay, I am going to be talking about Gil Hedley. To me, as far as I'm concerned, the top anatomist in the world. He has an absolutely fabulous understanding of the structure of the human body, first of all. Secondly, the interconnectedness of everything. Most doctors I have found specialize on one little thing, and you ask them a question about something else in the human body, they don't even know. Gil he's a top guy. Now, hold on a second. This is the paper I wrote long ago, 2015. It's called Fascia Facilitated Fossilization. I got a hold of Gil much earlier than this and came to the realization that the fascia, basically in the connective tissue, and the mechanicals of all this stuff is, this was 2015. And I realized it was, as the ancients used to call it, a tunica. It cloaks everything. Your nerves, your muscles, your tendons, your organs, your eyeballs, everything. And the fascia separates every cell and structure from its neighbors in life and after you're dead, if it happens in the right conditions and it doesn't turn into just festering mold, basically. And it protects every bit of you from invasion, including a complete fabric bag that's your skin. So I'm going to be talking about Gil's layers of the skin, the fascia, the superficial fascia, the muscle, what connect, all this stuff. But it's all made of collagens and keragens and creating fibers, elastins, sheets, and all this. It comes together as one giant system. I realized this in 2015 because I could see it in all my mud fossils. And I discussed all this with Gil. And he helped me tremendously. Now, I get into the chemistry and all that stuff now. And all the different types of collagens and keragens, and they have, some organs in your body have acids, and some have salts, and some have who knows what. But they have to be protected by a rubber bag. Now, you don't put a paper bag around gasoline, but you might put a paper bag around apples, and everything would be fine. Do you understand what I'm saying? The bag that surrounds these organs has to have the right chemistry. You need something that is not going to let that gasoline eat into it. So the chemistry within that bag, which is the fascia coating, has to have the right chemistry. That's where I come from. And Gil and I are going to have a thing this weekend, Sunday, on his live show, where I'm going to introduce his people to mud fossils. It's about time that mainstream sees this. This is all very, very true. And I knew all this back then, that the skin has 50 times the silicon as other tissue. Very, very tough stuff. And in my mud fossils, it was just silicon's just everywhere. I mean, it's everywhere because the salacious ooze came up under the ocean and created this unusual silica layer. So anyway, I kept going on about how it might even be fiber optic going through all these little tiny, because every single one of these cells in your body is touched by a tiny little tube of fascia. And it was thought to be packing material. And that's why they call Gil the fuzz guy, because he did the first videos in 2009. He did video on fuzz. And that's how I got a hold of him. I said, Gil, what's the deal with this fuzz? He says, well, it's just padding. And it pads in between the layers so that they don't scrub and they don't do this and that. And I said, well, there might be a little more to it. Can we discuss it? And absolutely. He was fabulous, and we did. And I worked with people over in Germany, too. I work primarily with sports doctors, because they were the ones that understood this, because this is when it rips and it tears and it balls up, and I'll show you all the injuries you can get. Anyway, fascia is suspected to be a source of many pains. Yes, I can guarantee you of that. Anyway, so I was in the fossils, the fascia and the fossils. And then I understood how everything transitioned into stone. And that was my paper. So, you know, it was one giant connective tissue system. And this is fascia. This was my paper again still. It did many experiments, and it was totally unexpected. Fascia is a tubular, fluid-filled fabric network throughout the body. And I did some experiments with chicken and this and that, but nothing really exotic. But I could see what was going on, locked in time. And I can even see damage. I'm going to show you some damage right now. I'm going to show you the depths of the layers that Gil talks about. Watch this. I looked up chat about Gil. They know he's one of the top in the world. Listen. You know, I am extremely proud to know this guy. Extremely open-minded, just as nicest guy you could ever meet. Now, it's Gil. He's not only smart and thorough. That's the key. Thorough. He asks questions, and he doesn't run away from things. Now, Gil is a well-known anatomist, educator, particularly recognized for his contribution in the field of human dissection and anatomy education. He just did a whole tour of the United States and Canada, giving lectures at wherever. And he gained significant recognition for his unique approach to teaching anatomy, focusing not just on the mechanical aspects, because he's a body guy. He understands the physical components of the body. So he also on the interconnectedness. Now listen to this. This is the key. The interconnectedness. You not just have a nut and a bolt. You're all part of the same system. The fascia, basically, and the body as a whole. Now here's the key. Hedley's teachings are centered on the importance of understanding the body's layers, and which I am going to show you in a second in a microscope. This will knock your socks off. First of all, you got your skin, then you got your superficial fascia, then you got your deep fascia, then you got your muscles. How do they work together? Where's the fluid-filled highway that I was talking about, the fluid-filled network? And what does that do for you as a human being in your immune system, and what does it do about fighting disease and so forth? He often emphasizes the importance of fascia. Yes, that's why Gil and I got together. The connective tissue that surrounds and supports organs, muscles, other body structures, 100%. Every single thing in your body has a coating. They can call it fascia. I call it a membrane. Call it whatever you want. He is also known for his philosophical approach to anatomy, discussing deeper meaning, like relaxation and so forth, of how you can make your body work within itself, to talk to itself. I mean, the guy he's deep. He's discussing the deeper meaning and connections between the body and your mind and your spirit in his workshop and presentations. Nicest guy you will ever meet, and the smartest I've seen. See, they called him the Fuzz. He's got an integral anatomy series. He's a real top guy. And he's also known for coining the term fuzz to describe the layer of loose connective tissue, part of the fascia. And at first, that was all they were thinking. Now, and he realized, though, that that could get stiff. And it forms between muscles, which can cause stiffness if not regularly moved or stretched. Now, this is how I got a hold of it, because he had a video, I think it was 2009, said, what about the fuzz or something like that? And it was about fascia. And that's when I got a hold of him. And I think by about 2011, he did another one. It's called Reconsidering the Fuzz, which is not just padding. And I could really show, and I can show you just stunning pictures, and I will, that I can prove these words that I'm saying. But Gil is the guy that he understands. He knows what I'm showing, and it's undeniable. But these are the layers. This is the key. This is going to knock you away. Wait till you see this. Because I have new species, too. That's a no-toe. And I'm going to show you the 3 layers right there. And I'm going to show you the blood running out. And I'm going to show you why I know how that thing died and what orientation it was in. Let's get started. Okay, this is just unbelievable. This is a foot of a creature I call no-toes. And that's the skin. And I will show you my belt in relation to this, and you'll see. Now, what are we seeing? Well, we're seeing the dark stuff here. It's just like the skin on the outside of here. Now, if I got all dried up, which I almost am, and this cracked open, I would be down underneath the skin. So where am I? From the skin to the superficial fascia, which is this brown looking stuff. And everywhere you see that, the skin has opened up. And I know why this skin has opened up here is because of the way this thing walked. It's just like a crease in your arm or wherever that it's always bending in that same spot. It's going to be, and this here is where the tibia came down, the big bone. And this is where the skin has peeled down. And this died laying like this. And you're going to say, oh, Roger, how do you know that? Well, I'll show you how I know it. Uno momento in the microscope. Now, so what are we looking at? We're looking at the skin. We're looking at the superficial fascia. And then below that, there's the fascia, then there's the deep fascia, then there's the muscle. Now, I'm not sure I can show you all that on here, but I certainly can in other ones that are literally meat, because you got to get down to the muscle. All right, above that is the fascia. And here is that spur lock. And this is what I'm going to talk to Gil about, because nobody knows about this. Gil doesn't know about it either. You know, he said I don't know what he knows. Let me put it that way. I don't want to put words in people's mouth, but I did ask him. I said, do you know that is a completely different body part? It's a different piece of material. This is another lung, and that is that material. This is a stripped lung. It just happened in nature from this particular preservation. And all of these are alveoli. The little balls are the part of the lung that are the little alveoli where the air comes in through here. And it's just completely stripped except for the spur lock. It's right there. And I believe we can see things in there. I'll show you in a microscope that kind of interesting. And this is the same thing, that right there. You see that? No, you probably can't. But these are the two, it's in all of them. But what I want to show you is the depth of the layers, starting with the skin, then the superficial fascia, then we'll get down into the deep fascia and all that stuff. All right, we've got the microscope coming down here, and we're going to be seeing the blood vessels, the black and the red, and I will show you why I know how this died. It was laying on this side. Now, I have to turn the lights off. And the first shot we're going to see up here is before I put any water on it. Now, it takes a minute for that to sink in. All right, now, you see the black spot on the bottom and the red spot at the top. That's the artery, that's the vein. So I've shown these things millions and zillions of times. And this whole area here is where the tibia comes down. Now I'm going to put a little water on there. I might have to let it sit for a second to just dry up, but it only takes a second or two. Whoops. And there it is. You see, I got this whole area completely covered with water. You see that? This is the area right here. Is where the bones, you see that round cradle? And that is where the vein and artery are. And they'll change a little bit in a second. Now, this right here, hold on, let me get my little pointer. This is the tibia, and it comes down and has a little hook that hangs over the edge. All right? This side right over here is the outside edge. If you go inside from there this way, this is the outside edge of the foot. If you go that way, you run into the fibula, which attaches on the side. Now let me dry this up a second. It's taking a little longer than I would have suspected. There must be a lot of moisture in the air. You see the black? That's the vein. That's a vein. That's the artery. And this stuff here is a slick, goopy stuff. And this is a bump. And over the top, like I said before, over the top of the bump, where are we? Is this piece here that hangs over, or would have hung over and rocked against this piece, I believe. You see how this is real slick looking? This is real slick looking in here too, because it's totally different than this stuff here. Absolutely a zillion times different. It's like a slippery, because the bone had a rock on there. It was coming down. That's the center of where it would have hit, and had the rock, and it rocked right on that surface there. If you know what a tibia looks like, it comes down, straight down like this as a bone, and then there's a little flap that comes over the side. That's this flap right here. And that's the center of the bone. And of course, this is where it would have slid back and forth in this little spot. Now, over here, slapped right up against this, was the fibula. And that's the second bone at your ankle. All right, this is the main bone comes up. Now, again, we had the black and the red. You see the black and the red? That fed that leg, or the leg fed the foot, that type of thing. Now, whenever I talk about fascia and superficial fascia, let me turn the lights up now. All right, now I'm going to turn, you know what, let me come down a little closer. You see what's going on in here? This is the bone socket area. Blood. Well, let me come right down on it so you can see it. Hold on, let me sync this stuff up. All right, that is the vein. And the veins seal right off. They don't like dribble out a lot. Normally. Sometimes they will under very strange circumstances, but normally if there's no big pressure on the system coming down this way, they'll just dry out, harden up like that, black. The red is different, watch. All right, keep your eye on this. I just put a little water on it. That's where the red blood side is. Remember I showed you where the black was, just a dot and it didn't bleed out? Well, these bleed out. They just run out because red blood is very fluidy. I mean, it's just fluidy as can be. So let's come down this. You see all that red blood running there? That's red blood running out. That's kind of globbed up red blood. And it came out of that whole area there. And it's coming down here, coming down, and running down and collecting way down here. See it? It's all over the place. That's, and I can't go any further, hold on. Twist this around, but you see all that's red blood. has red blood. And it's just runs out, and then it sort of globs up as red blood. Now let me just turn this down and see if we can see it. You see, that's the beauty of this microscope. You can get different frequencies of light which bring in different colorizations. It's just fabulous. Now, this, as you can see, is that fibrous stuff. And it's ripped open. Well, actually, this is the blood running over the top. But if we go from here in, where you see that white is the superficial fascia. All right, but there's blood all over this. Now, if you come down here, I gotta let that dry out. You know what? Let me focus this in. Let this dry out, and then I'm going to show you my belt. All right. Let me let that dry out. Okay. I got to be honest with you. I was delighted to hear that Gil was open to discussing these things. Because he's an honest guy. He's a good, smart, honest guy that knows what he's doing. Now, as we talked about the skin, okay, then you have the superficial fascia, and then the fascia, and then the muscle, and all these different layers. Now, the layer they missed was what they now call the interstitium. And here's why they missed it. Because it's a fluid-filled highway. In my paper, I said it was a fluid-filled network, was a giant system completely encased the whole body and everything, everywhere. And that's what protects you from invasion. It's as simple as that. And you have to have the right chemistry in here, which equates to enzymes, which means you have to have the right bacteria to create those enzymes to live in that layer. Simple as that. That's almost your immune system, because you can get penetrated here. You're going to get poked into here every now and then, but you got all the kind of guys coming over here to support you and kill whatever's coming if you have the right chemistry in here. Let's go past that, because there's a health aspect to this whole, very deep health aspect. Now, these are just the layers. So we've got the interstitium, which was, by the time they autopsied it, it was flat, and they thought it was a thick sheet of just like a piece of plastic that's coated it. And they knew it was a membrane, but they just didn't realize the complexity of it. So let's just go away from that. Because I've been looking back to see, how could they miss this? And they did find this. I know they knew there was a layer here, but they just didn't know much about it. Well, that's a real tricky subject. If you look deep, I think they knew about this. They just didn't know enough to describe it in a way that I could describe it, because I could see it. I knew what was going on. I could see it just like this, as you're seeing it right now. All right, so what didn't they understand? First of all, the chemistry that's in here, which is the enzymes, how quickly they react, millions of times faster than natural chemistry. An enzyme is a catalyst. Boop, done. And they work with half-lives, and they don't even get used up. They go around and do all kind of work, and then when they're not needed anyway, or they just get consumed. Now, what else did they miss? You see all these little tiny balls? I call them interstitium balls. And this layer right here, that layer right there, is where all your bacteria, I believe, lives. And this layer of tissue. Now, I can't be positive of this, and most of it, your bacteria lives there, and they squirt right out into the fluid-filled highway as needed, which is basically your lymph system. Now, can I show you this in gigantic human, or well, gigantic creatures? I'm not making any claims about human or whatever they were. But yes, I can show you this. And I can show you these balls and what happens to them. And I can show you the straps that hold those balls. Hold on. You see this? These are the Mars blueberries. This is the basement layer, and this is that interstitium layer, the balls are all that's left. Now, that's up on Mars, and then there's the Mars Morse code, which is not as eroded. Some of it is. You see the balls? Those are the blueberries. You see these stretched out straps? You see that? And then you see it all gathered up to here. Well, what would stretch out a strap like that? Why would these be stretched and these be pinched together? That's because that's the way the skin is gathered. It's gathered here, and these are high spots that sort of have eroded, dusted off. If you look at this carefully, that looks like somebody just sandblasted that. There is no erosion here, none, zero. So this is absolutely 100% for certain Mars. And this was all reported back in 2015. They found all this stuff and just go about their life without it. Who cares? I knew exactly what it was, and I reported it to all of them, every one of them. And I'm still reporting it all the time because it can't be missed. How can you not understand this is muscle sarcomeres? If somebody puts it in your face and says, "Did you see that, sir? Does that look like that? Does that look like that?" Well, yes. Do you think it might be that? Well, maybe. Do you think this is pretty close to that? Well, it sort of looks like that. How about this one, sir? This rock. Is that rock pretty much look like muscle sarcomeres? Well, some people might think so. Does that look like blood to you, sir? Red blood? Well, I mean, who knows? And let me ask you something else, sir. Do you know what a membrane is constructed of? Phospholipids. Do you know that the Bennu had phosphate surprise layers? And then they also had muscle sarcomeres inside those layers. That was the phosphate surprise. Did you know that our world is made of the same creatures? This is the Moki marbles. Just look them up. The same things as the Mars blueberries, identical. The straps are missing from them. And you say, well, what straps, Roger? Well, I'll show you those straps. Uno momento, monsieur. What is this? Well, that's the interstitium. There's the skin, there's the layer below, the superficial fascia, and then there's all the balls and the straps are in here, which held it all together, which kept it working. See, the balls and the straps and so forth are inside. Here's your skin, and here's all that webbing, which is the same as the Mars Morse code, and it has all these little straps and balls. All right, pay close attention. That's the top layer. Then there's this webbing of these balls and so forth. Now, can I demonstrate that in a number of ways? Absolutely. These are the blueberries on Mars. This is the Mars Morse code, which has some stretch straps. And I said I will show you the stretch ones. I'll show you. And my belt, my actual genuine cowhide belt. Now, where else do these balls show up on Earth? Well, they show up on the shores when the body of these gigantic creatures erodes away. And if they're in the fresh water and then they were in frozen environments such as this, they still have tons of biological edible material on them. So, you see all this green stuff? It's everywhere. You see these green balls? Why? You explain that to me. That still can't be explained. The most mysterious 12. I explain every one of them, every single one of them. Very simple. Once you understand mud fossils, these are the interstitium balls. That's what they are. Now, in the ocean, it's a whole different story. Did I show you this? Hold on. All right, here it is right here. This is Huntington Beach over in the United Kingdom. These are the balls that are in the salt water. And this is just being eroded away, eroded away, eroded. Skin, interstitium, the balls, and the straps are gone. Now, what happened to the muddy stuff here? It turned into mud. Here it is right here. This is not growing here like stromatolites. Oh yeah, all of a sudden they start growing. No, they're not going to start growing. They're attached to the balls that are eroding from that wall. That's what stromatolites are. They're attachments to something biological that's edible. And in the green ones, I mean, and it's got something, the red blood, these must be coated with a heavy amount of red blood, artery blood, because the vein blood does not grow this stuff. The vein blood, as I see it, grows lichen. Now, saturated in water like this, in fresh water, I don't know. I'd have to see what's underneath there, but I believe this primarily is reddish blood underneath that layer of green carpet. All right, this should blow your mind. This is, like I say, this is pretty good size. As you saw, all the other stuff was huge up there on Mars. Now, this is my belt. And all those shiny little spots are the black balls. And all the stuff in between is the straps. And you say, oh, Roger, I don't see any straps. And I said, well, that's because you didn't look the way I looked. Now, don't forget, that is my belt. And every one of those black balls is a anchor. Just as I claim, these are the balls and these straps are the anchors. Some can get stretched out like this. And if they get stretched too far, they pop right off. Let me show you my friend Tyson's tendon ball strap attached. All right, he's got an absolutely unbelievable spot. This is tendon ball. This is Tyson Carlson, Tyson's Mudfossil Adventures. Now, these are all these balls. They're all over. And here's one nicely attached to a strap. Just like I was showing you, these are attached to straps. Well, so is the ones in my belt. All right, so I'm going to show you that the ones in my belt are attached to straps as well. So let's go back up here. There is the bottom of my belt. When they tan these things, they roll them and they crush all these little balls and stuff, and they turn it into a mat so it's flexible. That's what a belt leather is. Now, I'm going to move over to where the belt buckle is, because that's where it has to do its stretching. You see the straps? You see the little straps? They're pulled out just like Tyson's was. You see that? The Earth is made of biology, it's creatures' bodies. All I can say is I am a material scientist. I present evidence. I don't present theories and say, oh, this guy's got to be crazy. You see, this is what we're looking at right there. Those are those straps. And every one of these has a strap attached to it. That's why it's so flexible. And they last forever. I mean, I've had this since forever. You know, I got so much to go over. I am going to do a real deep one, but this is Tyson's 6-foot thick bilipid membrane. That's the lower layer, that's the upper layer. These are the protein channels that allow things in and out. All of these little separations here like that, that's from the membrane where it had glue, literally glue or gooey stuff so that it could flop around like that, but it was not penetrable. That's what a membrane is. It's supposed to separate you. And look at the structure. There's the top, there's the bottom, there's what they call a lipid layer. All right, these are the phospholayers, and this is what a membrane is, right here. This is it. And the chemistry is there. There's no question you can see you'll find the chemistry. These are phospholipid layers. So there's going to be a lot of phosphates in here, both of those layers. And in between is whatever, it's a fluidy layer, glycolipid proteins or whatever. And they just sort of flush out easily. These layers are pretty substantial, as you saw. That's a pretty substantial layer. And so is the one above. Up in there, they just run out. This is pretty serious stuff. So I'm going to leave it where we started, but I am going to do a very extensive series as now that Gil is willing to speak a little bit about this. I just want to ask him for his interpretation of the things that I found. Because like I say, there's a new body part, again, outside of the interstitium, which was a new organ in 2018, there's a spurlock, which I found, which I am going to be going deeply into, and I have, and I want, hopefully, Gil at least to be able to take a look at things in his lab and see if he can find that same system. But I'm going to leave it where I started. Is NASA serious about searching for alien life? I haven't found that. I would like them to engage with what I'm saying. Bennu, there's no question. If you could, anybody, any doctor, I want a doctor to look at this and say, Roger, you're wrong, that's not correct. And sarcomeres aren't that. And phosphates don't have 2 layers like that. And everything I've said, I want somebody in the medical field to address. This right here is heart muscle. That's heart muscle. That's heart muscle. That's the phosphate layers, which are membranes. Phosphate surprise, they couldn't believe it. And I know what all of this is made of. I know the exact chemistry that will be, and this is the chemistry of blood. They landed right on a piece of blood, and I can show you that too. Here's where they say they landed. Anybody that knows mud fossils knows that the red, black, and the yellow is the colors of blood. The black is the used blood, the red is the really oxygenated, and the yellow is in a transitional state. So I don't know what else to say other than it's time to wake up and smell zero roses. Like, look at this. That's where they landed. This is what muscle looks like. These are the different colors. Red is the blood. And that's why there was so much blood here in between these blocks of layers in Turkey. The whole thing collapsed. And again, I've been trying to report that and hoping somebody in Turkey will pay attention, because this is what happened in Turkey. You see all those blocks I'm talking about? Here's what happened. The whole thing collapsed. These guys are standing up looking down. And I mean, this was big. This was big. It went way, 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 way all around. This huge. And it was a collapse. It wasn't an earthquake where it separated. These blocks just dropped. And that's because there was layers of blood in these blocks, which are sarcomeres. Because everything, as far as I could determine, there's nothing but body parts. And somehow this stuff ran off. So let's say this was twisted this way. And all the rains eventually ran that. Because this red blood runs. I show you that. Very, very simple. Red blood, very, very fluid. You'd leave these cavities, these canyons, these caves. And now in the sarcomeres, that's a dangerous place because they're blocky. They will break and separate quite easily. Well, I wouldn't say easily, but that's what happened. That's blood. Somewhere down below the bottom, there was a deep layer of blood somewhere underneath here that eroded away, and everything just collapsed into that cavity. That is, I mean, if anybody wants to say, Roger, you're crazy because of this, this, or that, don't just say I'm crazy. Don't just say that, because I'm fed up with that. People just, they come up and they make nasty, nasty comments with no, not saying you're wrong about this, you're wrong about that because of this or that. If I'm wrong, well, they're saying right here millions of years in one picture. That's not millions of years. That is actually a tendon right there, and that's the anchor of the tendon. I have one in my shop. I have one of everything basically, and all those little things has to move, and they have to slide back and forth, but just ever so much. And this is so tough. Tendons are the toughest things in the world. That's why it's still laying up there. The bone was here. I know that for a fact because that's where they anchor. Mine is exactly the same. And then the muscle would have started right here. There's an abrupt transition and the muscle goes. Exactly what I have in my shop. Okay, my friend. This just never gets any crazier. It's crazy, crazy, crazy. You see these spots here? This is a fingertip. And there's no question it's a fingertip. And this right here is where the apical tuft is. I've always shown this. And I had this thing kicking around. I meant to show this a number of times. That's the blood coming out of the artery side. And I know how this thing died exactly, and I know the conditions it died in. Now, this is the apical tuft. And let me show you what an apical tuft is. It's one of these right here. You see that? You see that? That's exactly identical. And they have balls all around here that hold the thing in place. I can't believe this myself. I'm blown away. Watch the pattern. It's exactly identical pattern. No difference whatsoever. No difference. So this sits right here. Unbelievable. Look at that. It even has the ball right at the end too. Now, so that's the tip. And this is the fingertip side. I mean the fingernail side. This is blood. I'm going to turn it over. Boy, this is amazing. Every time I see something, something new kicks up. Now, what is this, all this stuff here? That's blood. You see that? That's blood. Now, what are all those little different colors? Those are different colors in blood because blood is made out of metals. All right. Now, if I put a little water on there, which I will, you'll see the colors come out a little better. You know, it's not going to be fabulous, but let's see what we get. All right, you see, let's put it down this way. All right, let's tweak this puppy in. Oops, I gotta do some serious adjusting here. Take it easy, slow down. There we go. Now, it's wet, it's going to be reflective, so we're not going to see it all that good, but you see those colors? Let me bring up the light a little bit. Sometimes up or down. It depends on what frequency we're doing. Let's go down first of all. That's enough. And we're going to go back up to where it's very bright. And you can see all that blood came out the end of the tip. That's better. There we go. Now, you see that pile of blood right at the end of the tip here? That is where the artery was. And don't forget, isn't that something? This is just blowing my mind. The apical tuft is right there. Unreal. So this is where blood is. Now, how did it die? It had to die like this, where the blood was forcing its way down and it blew out of the artery. Otherwise, it really wouldn't blow out of the skin like that. Normally. The veins never do. This is the vein side. You see that? And you can see them on here. They just don't blow out. That's a vein. And over here somewhere is a vein. But that right there, they seal off. And then underneath, we got a lot of crystals and stuff formed where the attachment points were. Way at the back. I mean, I got so much to do with the microscope here that it's going to take some time. But this is some of my fun stuff. Look at that. That's all these metals collected here when the thing died because the tip was face straight down. And all the metals collected. Here's I believe that's got to be the main part of the bone or something. But that's the fingertip. All right. Okay, as you can see, I have a ton of support for my claims and statements. Blood, it comes down in the red blood, which is very, very fluidy, and it comes down, and there's two main spots on the side, and the two main veins on the other side. And this side, the fluid just runs out. But there it is here, here, and here. That's exactly what you see on the tips of fingers. That's how they're designed. Now this, again, I believe is a meteorite. And it's literally identical to this structure. This died and turned flat because it was in the flood. And again, they all have a flat side, and it died like that. Now this came through space, so it's not flat like this. and all the flesh just cooked off, and because there was so much red blood there, it exploded. And we will look at all this stuff closely in the next video, probably. You know, I have so much of this stuff that it's overwhelming, and sometimes it overwhelms me, but because I could just do this forever, which I have been doing. And so little interest is concerning. Very concerning, to be perfectly honest with you. Especially from the people that should be interested or have some interest, and especially with this. This has costed us billions and billions and billions and billions of dollars, and now they just launched something to go to Europa to see if there might be life on Europa out of Jupiter. Now, Jupiter's got another situation going on, and I think that's maybe what they are actually investigating. I have no idea anymore. I don't know what to think anymore, to be honest with you. There's no way that anybody could be this incompetent to miss all these things that I've shown you. It's just impossible, especially when you put it in somebody's face. And they say, oh, I don't want to see it. Is that competence? No, it's not. And that's what I found. And the same thing with my light experiments in Fermilab. And so it's ubiquitous, especially in government and academia, because they're just placed in their thrones of power. And that's why when they give it to somebody like SpaceX to do this, and they come back and they can save the rockets and everything, the government's never going to work that way. Because once you get a guy in power, it doesn't matter how competent he is, he's in power. In a real world, you got to be competent, or you just out you go. So that's the problem we got right now. Anyway, I'll let it go with that for today. Well, maybe not all for today, but stick around, because I'm going to go through a deep, deep analysis of what's coming through space. I have other stuff, the meteorites, the metal meteorites that have cooked off. And I've shown all the Comet 67P and Oumuamua, and every one of those is a body part. There was battles in the heavens and giants in the earth in those days. Love you all.